All right, so I'm going to go ahead and get started. I know there are people, I just got some emails, people said they're going to come in a little late, but that's fine. My name is Brian Campbell, and welcome everybody. This is the ICESat2 and Globe beta testing group, and we'll go over what that exactly means, but thank you for agreeing to be part of this cool project before you really knew exactly what you're going to get into. So hopefully we'll all get in it together. So we're excited about this. So the first thing I want to do is, I know everybody here probably isn't well-versed on Zoom. So it's just a pretty quick, it's such an easy interface. And what you're seeing now, you're seeing a screen probably with some, and depending upon if you have a MacBook or, a PC or whatever, or if you're on your cell phone or whatever, you'll see some images of the people who are using the webcam. You'll see who's all on board with webinar. But a couple cool things that I should let you know. When we do most of the webinars, when somebody else is talking, you can mute yourself, just so we just don't have a lot of feedback. We've had meetings where everybody, well, some people just didn't mute and we could hear your conversations, and you might not want people to hear, talking to the dogs or the cats or something like that. So I do it all the time when I'm at home. But you can do that, for most cases, you have a couple selections at the bottom left of your screen. There's a little microphone with a mute button. If you want to, you can press it to mute it, unpress it to unmute it. So, and then there's a video button. You can stop video or share video. One thing that's going to be pretty important for what we're going to do, not necessarily today on your end, but on my end, there's always an option for a share screen at the bottom. And that's really cool because you can just, if somebody's sharing a screen, you could ask them to, stop sharing screen, and then so you can share your screen. So we're really going to hopefully do that a bunch during this beta testing, because we really want to collaborate and really get interaction with each other and what we're doing. So sharing screen is important. So I am recording this because there's some people who couldn't make it today. So I will get probably a Google Drive link to the recording. Sometime by at least the end of the day here is pretty quickly on the East Coast, but first thing tomorrow morning, we'll have that link sent out after Zoom has to process it and then notify me on the cloud where it is. So what I'm going to do right now, I'm going to share my screen, and we're going to pop into this right away. We're going to jump right into it. Couple quick introductions. As I mentioned, my name is Brian Campbell, and I'm based at the NASA Wallops Flight Facility, which is a field office of the NASA Goddard Space Flight Center, which is based in Greenbelt, Maryland. And I work with the Globe program with several projects. I lead the Globe ENSO student research campaign. You might have heard of that. I know a bunch of you on here are part of that. I also work with the Globe Citizen Science program and the Globe Observer. And I work with several satellite missions. One right in here is the ICESat2 mission, the Ice Cloud and Land Elevation Satellite 2 satellite mission. I do education outreach for that. And also I work with the SMAP, Soil Moisture Active Passive mission. That's a joint satellite between NASA and NASA Goddard Space Flight Center and the NASA Jet Propulsion Laboratory in Pasadena, California. So today you're here for ICESat2. And I'm going to talk a little bit about briefly about what the ICESat2 mission is, and then get into what this beta testing is and what it means, and what the potential future of the Globe ICESat2 partnership will be. So really excited about this, and to get this going. It took a lot of back and forth between myself and Globe and ICESat2 folks, and so we're ready to get this started and ready to go. So I also want to introduce a couple people from NASA who are on the call. Dr. Tom Newman is on this webinar right now. He's going to say a few words a little later on, but he is the Deputy Project Scientist for the ICESat2 mission. That is, I should mention, that is a NASA Goddard Space Flight Center satellite mission. So it's led there at Goddard in Greenbelt, Maryland. And I believe I saw Valerie Casasanto is on here. She is the ICESat2 outreach and communication lead, manager for the ICESat2 mission. And she's on. I also saw that Dr. Eric Brown-de-Colston is on. Dr. Eric Brown-de-Colston, he is a Landsat mission scientist, among other things, but for our sake here, he's a Landsat, and he works a lot with land cover information and vegetation and NDVI and things like that. So we're going to be working with even though this is an ICESat2 led project here, collaboration, we're going to be working with scientists from all over NASA, I should say inside and outside of NASA. So we're excited about that. Oh, I should also mention, sorry, I forgot to mention this, but you will see as part of your options, you will see the chat room, which would be really cool if you can put in there, who you are and where you're from, because not everybody knows, but I see some, Jeff Bauman out of Michigan, my buddy Jeff and Valerie and Eric have mentioned things in the chat. So feel free to send a message out to everyone in the chat. You can just add it right there. It defaults to everyone. If you can send something to people directly as well, but if you want to get your name and everything out there from where you're from and who you are and where you're from, do that through the chat box. All right, so let's jump into this. So I'm going to right here. So everybody see this? Got a thumbs up? Get a thumbs up if you see this. All right, perfect. All right, so let me get this chat out of here. Get this out. So the ICESat2 mission. The ICESat2 mission is the Ice Cloud and Land Elevation Satellite 2, and what it is it's a mission it's a second mission that's going to be flying in space that will measure the height of everything on our planet, and it's going to be using an onboard laser altimeter system. So basically, it's going to be firing these safe lasers to the Earth's surface, and we're going to be able to calculate the time it takes the laser to leave the satellite, hit the Earth's surface, and bounce back to the satellite. And over time, over repeated time, that can give us the height of, everything on our planet. As you can see here, this is a graphic that is showing you, kind of an artist's rendition of what can happen. We're going to look at the heights of cities and apparently Ferris wheels, I see, and ice sheets and sea ice. And we have some geographic formations, clouds, tree canopies, and ocean surface. And the most important one for what we're doing here are tree heights. So we're looking at the height of canopies of individual trees. So because Globe has a protocol that allows you to do that, so we have modified that a little bit to get some of that information with the measurements that are taken. So yeah, so the ICESat2 satellite, and I should mention that the actual satellite launches September of 2018. And if Tom or Valerie, if that's the wrong time, I think that's right. September 2018 is when this is launched. So we want to have about a year's worth of beta testing data to go with until the satellite launches. So once we have the satellite launched, we can go from there. We can have some great measurements from the satellite and from the ground-based measurements by folks such as yourself and with all your students. So this is, I'm gonna not play this whole thing, but this is kind of it's going to show you, what the ICESat2 satellite will do. So what it's doing is it's flying around this orbit, and you will see that it's sending these laser pulses down, and it's mapping the height of our planet. And what we're going to get is we're going to get an entire planet's worth of data as it continues. So this is what I showed this to some students, and they said, "Will the Earth really look like that once you guys are done measuring it?" And no, unfortunately, it won't. I thought that'd be really cool, but that's something out of sci-fi. But no, it won't look like that because, of course, the laser light won't remain where it was just taking the measurements. But that's just showing you what the coverage is. So very exciting stuff. So I mentioned this is the second satellite of the name to be flown. So we had the first satellite was just called ICESat, Ice Cloud and Land Elevation Satellite. And it basically used a single laser beam. It had to take multiple passes because it had a single laser. So what it had to do is it had to take multiple passes to define to figure out the elevation change, basically because of measuring any slope. So with the ICESat2 will have this multi-beam pattern that will allow you the slope, the pair difference will give you that slope, so you don't have to take multiple passes. You will be able to get that elevation right away. So we're going to get a lot more data in a short amount of time with ICESat2 than we did with the original ICESat satellite. The original ICESat satellite flew from 2003 to 2009, taking these measurements. So we have a great, robust data set, but with ICESat2 and it's the advancing of the altimeter system on board, we're going to get a lot of data in a short amount of time, a lot more than the original ICESat satellite. But then technology, of course, advances, so you can expect that. Now, here's a video to show you exactly what I mean. This is a really cool video, and it's about 1.5 minutes or so, and it talks to one of the engineers about how exactly the ICESat2 satellite will take the measurements. This is important because the measurements that you and your students will take using the using the biometry tree height measurement one, we will then be able to use the data we get from what you're seeing here, and then compare that to the ground-based data that is being entered into GLOBE and has been taken using the GLOBE protocol.
The ATLAS instrument on the ICESat2 satellite measures elevation by timing the flight of laser light pulses that leave the satellite, bounce off the surface, and return to ATLAS. The speed of light is very fast, and so a regular stopwatch would give us too wide a range of time, a big margin of error. The timing has to be ultra precise, less than 1 billionth of a second, in order to measure the height of the surface within just a few centimeters.
I'm Phil Lors. I'm Deputy Instrument System Engineer on the ATLAS instrument on the ICESat2 mission. Calculating the elevation of the ice is all about time of flight. It's time of flight of the photon from the laser down to the surface of the ice and back. So what we are doing is creating time tags of the transmit when the laser fires and time tags of the receipt of the photon. So it all starts with the transmitter. When the laser fires, it puts out billions and billions of photons. We pick off a little bit of that, and we send it to a detector, and we produce a start pulse. And that is the start of our timing system. The spacecraft sends us a position and attitude message every second that tells us where we are in the orbit. From that, we calculate where we think the spots are on the ground. We have a rough database of the whole Earth with elevation as it travels up and down mountains and down into valleys and over ice sheets. For each spot, we calculate where we think the surface is, and we open up a range window. For every photon that's received in that range window, we produce a time tag. Now, the sun produces a lot of green photons too, many more than our laser does. So our laser produces billions and billions of photons with every shot. If you add the noise in there, you won't be able to tell the sun's photons from the laser photons. So if you just took one shot, the one laser photon would be lost in the noise. But if you take 200 shots, now finally you have enough surface signal coming out by the noise that flight software on board can pick out this is noise and this is the signal from the surface. Once we downlink the photon time tags from the receiver and the transmitter, and we have the range windows, you put those all together, you have the transmit time tags, you have the time until the range window opened, you have the receive time tags in the range window. You calculate all that put together, gives you the time of flight of a photon, which ultimately gives you the distance between the spacecraft and the ground. If you know where the spacecraft is, and you know the time of flight, you know the distance to the ground, now you have the elevation of the ice.
Technology that can measure elevation adds a third dimension to how we map our Earth and allows us to study change across the poles and beyond.
All right, so for our purposes, we're not going to be measuring the ice, we're going to be measuring the trees. So we're excited about this. I say this a lot because this is a long time coming that we actually can get this going, because doing the tree measurements using the protocol isn't the hardest protocol out there. It's not easy. It takes a little doing, and there's always going to be some type of margin of error, of course, when you use a handheld paper clinometer that you can build. So yeah, so the protocol is meant to be a guide be a guidance system for how you take the measurements. We always look, for people, if they figure out better ways to do it that gives more accuracy, we have no problem with that. Yes, we have the GLOBE protocols. Those are the guiding ones. We try to stick to them as much as possible. But if there's something that needs to work maybe a little better, it's always up for discussion. So it's one thing that we love to see, is that we see that innovation. So we might see that during this beta testing. And the reason why we're doing the beta testing is, with that 1 year of this beta testing, we want to get it so that we have as close to perfectly working order of a procedural order as we can for once we get the satellite data that starts coming in. All right, so those of you who aren't familiar with the GLOBE program, we have several things, just a couple bullet points. It's basically stands for Global Learning and Observation of Benefit the Environment. I'm going to mute everyone right now. Sorry about that. Right. All right, so Global Learning and Observations Benefit the Environment. So it's an international program of students, educators, scientists, citizen scientists who come together to study just basically environmental variables and take measurements and see how our planet responds to different things. So right now, a lot of the stuff we're doing is we're seeing how our planet responds to change, and the Earth changes, things happen in local environments that cause everything else to change. So we're really looking at it closely with a lot of these global protocols, and that's what scientists and researchers inside and outside of NASA are doing all the time. They're looking how things are changing. They're looking at change over time. I know that was coined, I think, by the Landsat mission, but a lot of the satellites out there, that's basically what they do. They're looking for changes, and changes can tell us what's happening with our planet. All right. Oh, so you should know, if you haven't known already, the simple URL to GLOBE is just www.globe.gov, G-O-V. So the GLOBE program and ICESat2. So as I mentioned earlier, the ICESat2 satellite has an onboard laser system that is used to measure the height of our planet, including ice sheets, sea surface, geographic landforms, clouds, tree canopies. We're focusing on the trees for this beta testing, and it's mentioned as a biometry. It's listed as a biometry protocol with the GLOBE program. Okay, so ICESat2 will know where on the planet the trees are that the satellite is measuring. The two things that we're going to use here, we're going to use GLOBE GPS, the GPS protocol, to identify the coordinates of each of the tree heights measured using the biometry protocol. So I'm going to, ask Tom Newman to say a little bit about, from the NASA science research side of things and the ICESat2 side of things, why it's important to have not just the satellite measurements, but also the ground-based measurements, which we can do here with the protocol.
Cool. Hey, Brian, can you hear me?
Yep, gotcha.
Cool. Thanks, Brian. So the other person that's on the call that's hiding a bit is Dr. Kelly Brunt. She's logged in as Kelly. And Kelly is our post-launch calibration lead for ICESat2. So ICESat2 will take these measurements of height all around the surface of the Earth in polar regions, deserts, forests, etc. But it's ground calibration that really tells us if what we're finding on ICESat2 is the truth. And so the great thing about the GLOBE program, as you know, is that it has participants all over the world. And what this protocol will allow the ICESat2 project to do is to verify that the heights we're reporting and we're measuring at places all over the planet are correct, and to what extent they are correct. So Kelly and I had worked pretty closely with Brian and Valerie in putting together this protocol that we know will give really useful data for ICESat2 for calibration purposes. But we're really interested in hearing from your perspective, from the user's perspective, as to whether this makes sense and whether this is something you can accomplish with your students and use it as an activity in your work. So I'm really looking forward to hearing your feedback about what you think about the plan. We think from our side, if this is something that works for you, it's going to be super useful for us. So that's all I was going to say, Brian.
Great. Thank you, Tom. I didn't know, Kelly, did you want to say anything? I unmuted you, Kelly, just in case.
Oh, can you hear me now?
Yep, I can hear you. Good.
Oh, great. Sorry. No, I think that was a fantastic intro by Tom. The only thing I'll say is it's exciting to see so many people on this call because, as you all know, like statistics just get better and better with, a higher number data set. So if everyone here represents a part of the N, a part of the data set, that's just fantastic. So thanks everybody for their participation.
Thank you, Kelly. All right. So I'm also, I don't want to put him on the spot, but I'm going to introduce Dr. Eric Brown to Colston and give him a minute or two to discuss quickly, how he sees, because Eric is not on the ICESat2 team. He works with the Landsat mission. So it's a kind of a different perspective. So Eric, you want to say anything?
Yes, I don't know if can you hear me?
Yep, I hear you, Eric. Loud and clear.
Yeah. Thanks for putting me on the spot there. I mean, I'm working with Landsat, but I've done, I'm a globe trainer as well on the biometry and land cover. And we're actually doing some work with urbanization as well. So I'm interested to see if you can do anything with building height as well, and just kind of listening in. We've done a lot of these protocols out in the field with schools, and it can be a lot of fun, and it can be challenging as well. But it's a really nice way to do hands-on science with your students.
Yeah, so true, Eric. Yeah, thank you. So yeah, he mentioned something that that we really want to focus on is that we want it to be fun, but it becomes challenging. For a lot of times that adds to the fun. We want it to be fun. We don't want it to be daunting. We don't want it to take away from, what you're doing in your classroom. We want this to serve as kind of a supplemental thing to your classes, and hopefully it will fit in. We're not looking for participation where you have to go out, to take a measurement every day or every hour or every day. That's not a necessity. Where it fits in, and once decide where we go further with this after this beta testing period, then constructive criticism, everything is good. I don't want to, just for this intro one, you're going to hear me talking a lot. I don't want to talk a lot with the webinars that we're going to have, because I want people to interact with one another. I want to do collaboration. I don't need to hear myself talk, but today it's just an intro, so it's good. So I apologize for all the talking I do today, but hopefully we'll get some people talking, collaborating, sharing ideas and procedures and all that, in the future. So yeah, so great. So that's kind of a great way to lead into what we're hoping to do, once we get through the beta testing period. So as I mentioned, we're using the two protocols. And what we try to do with the globe stuff is that once students are taking all this data, we end up getting all this data, this data density, building up. So what do we do with that? So we always like to push it to the next level to see where this data can take them in the sense of creating research projects where they can take the data and make sense of the data. Yes, they'll have a height measurement, but how do they use that? Scientists and researchers do that all the time. They get the data, but then they apply it to different things. All satellite missions and campaigns, have an applied science program. So there are all these applications out there, for the data that you get in. So that's the only way for us to figure out what this data means and why it's important, to apply it to the real world. And that's what we're trying to do here, as best as we can. So with that said, what we are hoping is in the future that this will become an official Globe campaign. Okay, I have submitted information to Globe as, submitted a request to make this an official campaign. It won't be a huge campaign like the ENSO one or you know, the I believe the Mission Earth one as well with Globe, because those use multiple protocols. With the ENSO campaign, right now, I think we're utilizing almost 20 of the Globe protocols as part of it. So we're definitely not going to be that big. We don't want to be that big because we want to fine tune it to this tree height and make everything with this tree height and elevation stuff, you know, as fine tuned as possible. But if this becomes a campaign, we will focus on several webinars. You know, we'll have scientific research presentations from inside and outside of NASA, Globe student teacher presentations, and definitely networking and sharing ideas, collaboration. And we'll have some regular blogs and some social media posts. I hope to hear yay or nay from Globe in the next, I'm going to say next month or so. That's what I was told, maybe a month or so. So sometime mid-fall, I should know. So, but we'll keep everybody on board. So hopefully, you know, fingers crossed for that. Now, so let's go a little bit into these protocols that we're going to be measuring. They're super simple as far as the material to learn them and figure them out. I mean, there's a couple things. I should also mention that probably not all of you are Globe members, and I have a little thing at the end of the website you can go right to the Globe website and join. Most of it's pretty easy. Some things get a little complicated, but I have a slide here that I'll share with you with some links that can take you directly to doing that. And remember, I'm always available if you run into anything, any problems. You know, you can ping me just at the email that gets sent to you. That's brian.a.campbell@nasa.gov. But also, if you have some big problem, you know, you can always go to the Globe Help Desk. That's just help@globe.gov is their address, and you can send them your problem. So that's help@globe.gov, and that will send a message directly to the help desk. You will get an immediate, you know, message acknowledging the receipt of it into their system. So you'll be placed in the queue, and the queue, they're pretty fast right now with that, and they'll get back to you as soon as they can with the problem, and they're really good at, you know, figuring out whatever's wrong on your end versus their end. So the GPS protocol, these measurements are used to determine latitude, longitude, and elevation of your school, the Globe sites, and the tree measured. Now, when you go in, and a lot of you I see on here already have sites defined, but when you go in and register as a teacher, you can also register as a scientist, but the majority of you will register as teachers, and you go in there and you just have to, you know, find the lat long of your location of your site where you want to be defined, like if it's your school or you know, if it's at home or whatever. You can define that. Then you can add subsites underneath there, just locations that you want it to fall under the umbrella of your, you know, of your school. You know, you can add student accounts, and I know at one webinar in the future, I'm definitely going to ping Jeff Bauman out of Shumate Middle School in Gibraltar, Michigan. He's on right now to discuss. You know, I know he added a bunch of, I believe, some student sites, you know, where they can put the measurements in, you know, based upon the students in his classroom. So, you know, that takes another level of understanding, but Jeff is doing it really well. So the GPS protocol basically calls for the following: latitude, longitude, elevation, time, and satellites if you're using a GPS receiver. Okay. Some people use their, you know, the protocol asks for lat long. You know, nowadays, you know, you can use your cell phone. The accuracy is pretty good if you have a location turned on. But if you're still using a GPS receiver, it'll ask you like the number of satellites, if it's in 2D or 3D mode. So you'll see all that in the protocol. It's required when a new study site is created or defined. Let's say you have a study site, you know, set up on Globe, and you want to set up a new site. You're going to have to find the lat long and elevation and the time, you know, when you set it up, all for that new site. And a protocol will also be used when you're measuring the height of trees. Because the ICESat2 satellite will know where these trees are, they will know the location on the planet where these trees are, they're measuring the height. In order for us to help validate that data, as Tom and Kelly mentioned, we need to know what the lat long is and the elevation is at the base of your tree. So what we have it set up, and we'll get into in a second, is, you know, when you take a measurement of a tree, you will find the lat long and elevation at the base of the tree. So that'll really help to fine tune that data in for ICESat2 and, you know, your further measurements. Yeah, and I mentioned here, if you need be, you can use the lat long information for your phone. There's more info about this in the protocol. All right, so here's just what the GPS protocol looks like. This is just the data sheet from it. Okay, this is the static data sheet. This is what it, you know, it doesn't look exactly like this when you do it online. This is just the information that you would take if you're not near a computer. You just write all this stuff down, then it'll ask for it once you put in the information. So as you can see, 5 observations, and that's important because we will be doing 5 trees. So that's what we're asking for in the biometry protocol. So this happens to be set up well, because we did not change this GPS protocol at all. This is set up the way it is. But it's when you define your site, it's when you need to do this. And when you measure the tree height of a base of a tree, you have to follow this procedure. And with the protocols, there's the overarching protocol. There are the study guides, which tells you what exactly to do. And then there's the data sheet, which has the information you need to fill in. So you have latitude, longitude, elevation, time, and if you're using the GPS unit, number of satellites, and then if it's in 2D or 3D mode. And there's explanations all about that in that. So the biometry tree height protocol, this is probably the backbone of the mini campaign that we're doing now with the beta testing. Protocol asks for the tree species. Now, we didn't change that because that's information that can be used by other scientists and researchers. It asks for what type of tree you're basically looking at. If it's, you know, deciduous, coniferous, you know, what type, you know, basically what type of tree. Along with the height and latitude, longitude measurements, and that's it, okay? The trickiest part, we'll be doing the height because there are actually 4 separate protocols to measure height, because you can be on basically level ground and you would use something called the simplified technique using a clinometer. So basically, no, actually, simplified technique using a clinometer. So it's pretty simple stuff. And you know, we'll go through that, you know, in future webinars, but you can read all about that. And I know some of you have already done that before. So we will be focusing on 5 trees, and you will see on, I will go here real quickly, on this data sheet. This is what the science, let's go here first. This is what it looks like when you go to enter the data. It asks for like what type of tree, and then you can see here at the rectangles on the bottom, tree 1, tree 2, tree 3, and you can add up to, I believe, 5 on this, and that'll ask for a height. So you can add these different heights in here. You know, you can add the circumference. Yeah, I mean, all these boxes don't need to be filled out, but they will have it set up, I believe, so that you will have to include height, one height, the latitude and longitude, and the elevation at the base of the tree, and those are all part of the study guides and the field guides and the data sheets. I'm going to hop back here. So this is just artist's rendition of, you know, someone looking at the tree height using several of the techniques. And we don't have time to go over every single part of the technique right now because that's, you know, where I'm going to send you to look at the information. But here's an example of the clinometer. So it's simply it's graph paper with this basically protractor drawn on here, and then you tape a straw to the upper right edge of it, and then that's what you look through to find the angle to the top of the tree using this clinometer. And I'm sure there's maybe some questions in here. I will get to those in a second. All right. So getting started with Globe, if you're not a part of it, you just go to the globe.gov website, and you can do www.globe.gov/join. And then this is a whole section here on the second one here using the Globe website. I don't know everybody here if they're a Globe member or not, but you know, I will send this presentation out after this webinar. I won't include the videos because it'll be too big to send, but I will include all the information that you need, to get onto the website. And then we have a couple resources. And so I will show photo photon in a little bit once we check for some questions here. Stop my share. Chat. We go to chat room. All right. So I see the first question, and maybe Eric, can you maybe answer this question? You might know. The question is, how accurate is it to use Google Earth to obtain lat long and elevation data?
Your question, very good question. I don't know off the top of my head. I'm sorry.
Okay, yeah, I don't know that answer specifically. I mean, I'm sure, I'm not even going to guess at that, but it's a good thing that we'll have to research and find out for that.
Hey, Brian?
Yeah, Tom.
Yeah, the locations for ICESat2 are good to about 6.5 meters.
Okay.
Most of the imagery, it really depends where you are on the Earth as to what the accuracy of a lat long you would get from Google Earth would be. I'm not sure if Kelly's still on, but I know she's looked at this kind of thing more than I have. Does Kelly want to hazard a guess? Sounds like she does.
I'm trying.
Oh, she's trying to. Hey, Kelly.
Hey, how's it going? Yeah, you're absolutely right. It really depends here or there. It's sometimes very hard, especially actually where we're most interested in the polar regions, to line up lats and longs from the imagery. So yeah, in school system areas though, I'd like to think that you're down to about 2 meters in Google Earth.
That's kind of what I was going to guess, which I think leads me to conclude that you could use Google Earth to get enough lats and longs for our purposes.
Yeah, that sounds right. So yeah, barring us finding out, conflicting information, I'd say, go ahead and, I think that would be accurate enough for our purposes. And then I see, yes, I'll provide the links for the videos in replacement of the videos that are actually there. I will put a link to the videos so you can go to them. Yeah, for sure.
And Brian, if I remember correctly, the Globe was also going to look into, what are the accuracies of, so if you wanted to use the GPS on your phone as well, if you don't have access to a full GPS unit, the kinds of errors that you might make. Obviously, when you're in a dense forest as well, you have issues with the signal, but in any case, I mean, these are things that I think Globe was going to do some analysis on that. I don't know if they did.
Yeah, I know they did do that, and I believe they're adding it to the part of the that introductory information that you get for each one of the protocols.
Okay.
I think it might be it should be in there. I have to look because I actually heard them talking about that last week, but I'm not sure to what status they are of that. So we'll have to look into that too. So does anybody have any questions, or are you thoroughly confused about what's going on or what to do? Please, unmute yourself and you can speak up. We're all here for discussion.
Hey, Brian, I had one comment for Chris.
Yeah.
Chris, all the ICESat2 elevations are referenced to the WGS84 ellipsoid. So if you have the option, ellipsoidal heights would be most useful if you have an absolute elevation box to fill in.
All right. Anybody else?
So can you use, I have a program on my phone that I use for driving, and I'm trying to think of what it's called, Waze. I don't know if that doesn't necessarily give you longitudinal.
Yeah, I don't know. I know of that. Yeah, I know of that mapping. It tells you where to go, and it says, what's construction zones and all that stuff, part of it, speed traps and all that. But yeah, I don't know that technology well enough.
Brian, am I unmuted?
Yes, you're unmuted. Yep.
Yeah, so I would argue heavily against using navigation software because ultimately what's making those work is it's snapping your position to a known road. In other words, you show up actually in the center of the road and not, where the error associated with that program actually lies, not on the sidewalks. So that's snapping your position. So even if you can get a lat long out of that, and I don't really think you can, don't use it. But if you have almost any cell phone that you could run Waze on, usually there is something called a Compass as an app, like on the iPhones. I'm sure they call it something GPS or Compass on the other OSs. But inside Compass on iPhones, if you look at the very bottom, there's your lat long and elevation. That elevation is off, but it's good for us right now. You can go with that.
Hey, Brian, this is Chris Parrish. Am I unmuted?
Yep, you're good.
I just wanted to respond to Tom's comment and thanks. And this might be getting really too technical, but this question of differences between ellipsoid heights and orthometric heights, the latter being something roughly equivalent to mean sea level heights. Some GPS receivers, I've got a Garmin eTrex that cost about $100 that I picked up at a Target or something like that. It actually tries to correct to orthometric heights, heights, again, loosely equivalent to like a mean sea level height. Other GPS receivers don't, and that's a pretty big difference. Here where I am, it's about 30 meters. So that could be, if you've got some teachers and students giving you one kind of height and some giving a different kind of height, those could result in pretty big differences.
Yep, that's a good point, Chris. I didn't realize you were Chris Parrish. Good to hear from you.
Hey, Tom.
All right, anybody else? This is exactly what we need for this, and we'll have lots of these sessions to chat about what works, what doesn't work, what can be used, what can't be used. That's good.
So
yeah.
I have a question. I'm not familiar with the GPS protocol. Looking at the data sheet, is that just practicing how to use a GPS with students, getting them out there, trying it out, and then you take 5 measurements with that, and then you would GPS the base of the tree to calculate the height? I mean, is that what I'm hearing here? I'm a little confused on that one.
So the GPS protocol isn't a sense of a protocol that you're submitting data all the time, but you have to do that protocol in order to set up, basically set up the site, or to get the same procedure to set up the site, to get the lat long elevation of the site. So what we're going to do is with the final step in the tree height measurements is you take the tree height measurements, you do all that, you get, figure out the angle, get the tree height measurement, and then at the base of the tree, you would then just look at do the procedure of the GPS protocol to get that. You would get the lat long and elevation at the base of the tree. So yeah, so it's basically the GPS protocol is just a procedural thing. It's not, in the sense of the other protocols where you're entering data for those protocols all the time. But when you're taking the tree height measurements, you'll have to just look at that procedure to get that. We do it that way. Because we can't just say, write down the lat long, because it has to be done via the GLOBE protocol, the GPS protocol. I don't like the term protocol for that actual measurement. So you can just simply call it GPS measurement.
Yeah, Brian, if I could add, the original idea was when you set up a site is for land cover measurement, and so you would maybe go back to that same site over time, make different measurements. So you want to have an accurate location. It was tied to a Landsat type pixel, and so you wanted to know the location of the center of that pixel essentially. So that you can tie it back to the satellite. Here, you're averaging the 5 measurements to get sort of your average position for that point. And here, from my understanding, is you do the same, but at different locations for trees within your site. I don't know if that makes sense.
This is Kelly. I'll just add in one other thing. what we're trying to get you to do is stand at one site away from the tree, get your position,
Okay.
then using the inclinometer, get the height of the tree, and then get a position of the base of the tree. From the base of the tree, you can't tell me the GPS of the top of the tree. You can only get it from standing removed and using the inclinometer.
Right.
So getting the GPS position is associated with standing in one place where you're using the inclinometer, and then walking over to the base of the tree to tell us exactly where you were aiming that inclinometer. Does that make sense?
Yeah. My next question, as teacher brain here, is in reality, how much data do you want? How often do you want this? And I know it's beta and you're figuring it out, but I'd like to have a good idea here. I mean, we do soil moisture, surface temp, soil temp, clouds every day, every hour at Shoemate. My buddy Femi needs my data, so I'm taking it for him. And we do as much as we can, and I mean, what are you thinking, just out of curiosity, how often?
This is Kelly again. I think that's a really good question. I think we're going to have to do a little bit of sort of experiments on what a class can accomplish. The other thing that we don't have a sense of is age group. Some of the older kids might do this a little bit quicker than the younger kids. If you can get us 10 assessments in a class period, I think that's really good. And I'm trying to give that number for the broad, for the young to the older groups. So adding on to that with bigger class, it could break up into small groups because they're mature and whatnot. If you got 30 sites, 30 is a magic number in statistics. So anywhere to 10 to 30 based on age, I think that's reasonable for us. That's in one class sitting. Our satellite goes over it's in a repeat orbit, which repeats every 90 days, so every quarter, every 3 months. If you did this a couple times a semester, that'd be fantastic. Does that get us close to what you're looking for?
Yeah. I mean, with other measurements, like I said, that, we go outside every hour. I've got 2 kids, my class, Mr. K's class, they go outside, they're trained. They take 2 other kids per hour, and they go outside, they take 5 to 7 measurements every hour, times 4. And that's how we do it every day at Shoemate. I know with, let's say, like the Aaron project that David Bidlowski and Andy Henry and Jeff Bland and Brian are trying to do here with kites and stuff, it's taking measurements as often and whenever you can. There's really nothing, tied to it. It's just when it's windy, you can get a kite up. But I was just curious as to this, because that's usually one of the first questions a teacher's going to ask you is, how much do you want? How often do I have to do this? What's the commitment? I'll do it as often as I can. That's just how I roll. But, I'm just curious, because I don't want to miss your mark. So
I think we're pretty open-minded. And I think as we see some classrooms that maybe get really into it, I think we might reach out to those guys specifically and see if we can help you, figure out how to be more. If somebody's that engaged, I think we have a sense of responsibility. We should probably turn around and see what we can do to help out as well.
Cool. I'm good. Thank you.
Kelly, so in a perfect world, what would you want to have them do when they go out? Like, would you really want them to go out every day, or is it okay just to go out every couple days? Or, you want that measurement of one point on the ground, a flat area, right? Like a basketball field or a football field. And then you want the height of the tree, and then you want the GPS measurement at the base of the tree. Correct? And how many?
That's exactly right.
How many data points?
So from my perspective, trees change on seasonal basis. So if a class got me 30 of those data points or more, not too much more, I don't mean that, but let's think about statistics here. If class got me 30 of those data points per season, I'd be pretty happy. If a class wanted to do more, that's just better statistics, beating down some of the air. So I think that's what we're looking at, 30, good tree heights per class per quarter. Anything else is gravy.
And Kelly, just a comment that brought to mind. This is Eric Brown. We were measuring more like percent tree cover on a repeat basis with the GLOBE protocols. And so one of the things that Jeff mentioned is if you had a class going to measure the same tree or the same stands of trees, every day, you also might start getting a feel for the sorts of, the uncertainty in the measurement. And that would be a good thing, I think. If different kids went out and measured the same tree on a daily basis, you would sort of get an error or a bound of their result. And that would be.
Absolutely. Absolutely. What I don't want to do is make a request of all schools that they have to go out daily. At a base, I'd just love to see the 30 measurements per class per quarter.
Right.
But you're right. Helping us get error for the classes that have more of a commitment, possibly older kids, possibly people that are just embracing this fully in a lot of other applications. You're right. A daily measurement could certainly be extremely useful.
Sounded like Jeff's class was volunteering.
I know. I'm going to get his number.
You know what? I was in when I signed on. I'm game for this. Let's do this. I can't wait. I mean, what are we talking for? Let's go do some measurements now.
All right, we can stop the recording now and get Jeff out there. Yeah. All right. So what I'm going to do after this, after we adjourn, is I will get the presentation together and I will shoot it out to everybody so you have it. And then once I get Zoom cloud lets me know that this recording is ready, I will get that out as well. So I know a lot of you. Don't know some of you, but you can come to me with any questions, and if I don't have the answer, we have a great team, as you can see, we have great dedication from our folks at NASA, and I see some other university folks out there as well. So very cool stuff. So it's definitely, it's definitely important, and you guys see that it's an important thing to do. It helps you become part of a NASA mission. I know some of you on here are part of lots of NASA missions and measurements and stuff, and have been around, taking the measurements for some time now for different missions. But yeah, so this is, we're excited about this. And, my suggestion is, get started taking some of the measurements, and the goal of this is to beat Jeff, is to see who can do more. Jeff's going to take that as a challenge because, his whole classroom is set up to do amazing measurement stuff. So, yeah. But yeah, as Kelly mentioned, that 30 is a great number, and anything, over and above that, then we get the good data density, and we can, figure out, good data, bad data, all that stuff. But yeah, so we're really excited that you guys are coming on, and hopefully at the next webinar, which we'll have, we'll probably, I'll ping you guys in, off and on, but we'll have another webinar, say within a month or so, to see how everything's going. So, my suggestion is, take a look at the presentation that I send you, because it has where you can get started and where the protocols are to go find, where do you find the protocols. I know some of you are familiar, some maybe not. Those of you who aren't familiar, ping me with any questions, and, we'll guide you through. Or as I mentioned, if you're having a problem internally with the GLOBE system, that, something's not working, you just help at globe.gov. And they'll get back to you pretty soon. But, if you don't want to wait for them, just ping me and I'll see if I can answer that for you. Because there are some things on GLOBE that I can't do. I don't have permissions to do because I'm at NASA, I'm not at GLOBE. But, so yeah, so exciting stuff. Anybody else have any parting thoughts, suggestions, ideas?
I have a question about the clinometers. I know that I was at a workshop over the summer with you, and I need to know how to make clinometers that I can use in my classroom, because I never got a copy of the paper that was the protocol or whatever she used.
Okay. So what we're going to, on the GLOBE website, there's things how to make a clinometer, but what we're doing to simplify that a little bit is, one of the people's on our team, Addie, she is finalizing basically an official, it's a sheet with the ICESat2, like this slide that you saw earlier. This yeah, I'm gonna go back to this one here. Like this here, like this slide. So she's finalizing that, and then she will put it up. There's a couple typos and stuff she's working out, but we'll put that up on the ICESat2 website, and once that's up there, I will let everybody know that that's up there. So that clinometer will be there and ready to go. So, and it's as simple as that piece of paper, and you take 2 pieces of tape and a drinking straw. Preferably a drinking straw that doesn't have the bendable neck, because we've used those before and they just don't stay straight, of course. So, yeah, but that's basically. Oh, and then it's attaching a string and a couple washers on it. But it's really simple stuff. But once that's up there, it's a great question. Thank you for reminding me. Once that's up there, I'll ping everybody and say, hey, there it is. You can grab it, because we don't have an official presence, ICESat2 presence on the Globe website yet. Once I get notification for that, I have a whole slew of things that I want to get up there so we can have a central location for getting all this information. But right now, we don't have it. It's just we're just waiting for some answers from Globe to get that ready. If not, what we'll do is we will pop a couple things up on our ICESat2 website and go from there. I saw it'd be good to have from Eric Brown. Oh yeah, cool. So yeah, to have a short video showing how to make the clinometer. That's good. Globe may have that, and I will ping them and find out if they do or not. And then that would be great. Peter from Oregon, he mentioned that, can you request to get this in the Globe mobile data entry app? Yeah, that is in discussions right now. That's a whole new can of worms. So we are actually working on that, now. So I'm not saying that we're putting it in it right now, but we're figuring out how to do it the best we can. So I know the folks at SSAI who work with GIO, who design the app and get all the stuff up there. They're working on that.
Right, because that one you could use an actual built-in clinometer on your app.
Yeah.
You could build that in so that, although it is fun to build your own.
And on the app, that was mentioned earlier, on the app you get the lat long. And another important thing is that if you use the app already, you know that you can get pinged when the satellites are coming overhead, the ones that measure clouds, to say go out and take a cloud measurement. So we will know where the ICESat2 satellite will be flying. So we can have that same capability on the app, with this, because we can have it set up to you get pinged when the when ICESat2 is going to be flying overhead to get the measurements. Because most of you know that, with the cloud part of the Globe Server app, if you take a measurement when the satellite is overhead or nearby, you'll get an email probably the next day saying, here's your data, and next to it will be the satellite data, so you can do comparisons and contrasting with that. We've had students, look at that data that they've done that, and then they do some research projects on that. So hopefully, fingers crossed, we'll get that in. First, order of business is to have you guys and your students, introduce to your students, take measurements, and let us know how everything's going, and then also to get this, information is most, onto the Globe website. But that, I don't know how long that's going to be. That's not in my court right now. So it's Globe is deciding that. All right. Anything else? Good discussion in the chat. All right. So it is 5:02, and that was about an hour. So we'll get back in, within a month or so. But if you have any questions, let me know, and let's start getting some of those measurements in. And we're here to help. We don't want it to be daunting. That's the least thing we want. We want the measurements, but we don't want it to be daunting, and we don't want you to leave us, because you guys are the ones who are setting it up so that if for once the satellite launches, we have everything fine-tuned. So. Yeah, and we know that if we were doing this 20 years ago in the technology we had, it'd be completely different. But so many different forms of technology out there that we will run into some things that will work better than what we think will work. So, all right. So I will adjourn this meeting. I will stop recording, and thank you all so much for joining in the discussion.